So let's go ahead and say that rather than flipping a coin, we're actually rolling a dice. We're going to start with a normal 6-sided die here, and so the question is, okay, if I roll the dice once, how many options do I have? Well, I know with a 6-sided die I can get 1, 2, 3, 4, 5, or 6. So in reality, it looks like I have 6 options in my sample space. Well, if I want to roll it a second time, then I can try and visualize this using a tree diagram. That is, in the beginning I had a branch for 1, 2, 3, 4, 5, and 6. If I want to roll it again, each of these will also have 6 branches coming off of it. And I could do that for each one, but at that point I had 6 initial branches, and each of those has 6 on them, which means it looks like I have 6 times 6, or 36 total options if I continue that out. Our goal here is to take that formula we derived before and go ahead and apply it to this. That is, we know for flipping a coin, we had 2 to the n options, where n is the number of flips. We can go ahead and generalize this to dice as well by understanding that with a coin we had 2 to the n because there were 2 options when we flipped a coin. Here we no longer have 2 options each time, rather we have 6. That is, once again, number of possible outcomes from one trial. That is, if I flip it once, or roll it once, this is the number of options I have. Now, I'm not just rolling the dice once, right? In the case over here, I'm rolling it twice. So this would be 6 to the 2, because I have 2 rolls, or 36 total options. If I roll the dice 3 times, then it'd be like 6 cubed, 4 times 6 to the 4th. In general, what this allows us to say is we can take the number of possible outcomes for one trial and take it to the power of the number of trials we're running, and this will give us the count in our sample space. So for instance, if I want to go ahead and roll a d12, a 12-sided dice instead of 6-sided, I would take 12 to a power. If I had 3 options instead, I would take 3 to the power. So this is generalizable to a bunch of different types of things.